This video is a live recording of the demo of the INTIX transaction tracker. The demonstration of the INTIX transaction tracker illustrates the processing of outgoing payment instructions initiated on the electronic banking channel. For the purpose of demonstrating the tracking of transactions, 15 interception points have been defined, capturing different status transitions in the transaction lifecycle. Some interception points are related to the transfer of control between different systems, while other interception points reflect in-system status changes. The basic flow of a transaction starts in the electronic banking system, where transactions are initiated, signed, and then released. It continues in the core banking system, with an optional step for AML profiling. After release by the core banking system, transaction processing is orchestrated by a middleware component, covering the exchange of transaction messages and acknowledgements over the SWIFT network, up to the registration of the completion of the transaction lifecycle in the core banking and the electronic banking systems. We log on to the system using a standard web browser. We select a transaction dashboard in the system. As there are no transactions in the system yet, the dashboard is still empty. For the purpose of this demonstration, we will start the processing of 1,250 transactions with value date today in various currencies. The crosstab portlet at the top of the dashboard will group transactions based on the transaction status in the rows and the cutoff time in the columns. For each status and cutoff time, both the number of transactions and the counter value in euro are shown. The bar chart at the bottom of the dashboard provides the same information, presenting cutoff time buckets on the horizontal axis and using the transaction status as series. These transactions are signed by the customer. As transactions are flowing through the transaction processing infrastructure, the dashboard automatically updates. The bulk of these transactions get released in the electronic banking system. The bulk of these transactions are created in the core banking system. We select a different dashboard that provides a graphical volume perspective on transactions. The crosstab portlet at the top of this dashboard is identical to the previous dashboard. The bar chart now reflects the number of transactions, with the transaction status on the horizontal axis and the transaction currencies as series. While the previous dashboard will easily highlight a high-value transaction, this dashboard will easily highlight a large volume of smaller transactions. 20% of the transactions go into AML profiling. We can drill down on any number in the crosstab portlet to get a view of the underlying transaction data. We can drill down on an individual transaction to see all events and messages related to the processing of this transaction. We switch to the value perspective once more to watch the part of the transaction processing related to the exchange of messages. After transactions are released by the core banking system, the exchange of messages over the SWIFT network is orchestrated by the middleware component. The transaction status now changes as a message for that transaction is exchanged between systems. Core banking sends empty messages to the middleware. The middleware forwards the message to the SWIFT network. The middleware receives an acknowledgement from the SWIFT network. The middleware forwards the acknowledgement to core banking. The middleware forwards the acknowledgement to the enterprise bus in an XML format. Completion of the transaction lifecycle is registered in the electronic banking system. The dashboard now only includes transactions that are in a non-final status. Once 90% of the transactions have reached final status, the residual data on the dashboard represents the 10% of the transactions that are in flight. We now switch to a dashboard that lists transactions that require an alert to be triggered. The portlet on the right-hand side lists EUR transactions that are near to cut-off time. We switch to another dashboard to demonstrate more analytics on final transactions. This dashboard provides a value perspective on final transactions. At the top, we see the transaction value over cut-off time buckets, split out in function of whether they reached final status before cut-off time. In the middle, the same information presented graphically as a bar chart. At the bottom, a view on transactions processed during the day, with the processing time on the horizontal axis, again expressed in their euro counter value and split out in function of cut-off time breaches. We drill down on euro transactions that did not breach cut-off time, representing almost 300,000 euros. The amount consists of over 300 different transactions. By clicking on the transaction history becomes available, consisting of the sequence of events that have been registered for the transaction. By clicking on an event, in this case the message exchanged from the middleware to SWIFT, all the event characteristics are available. The event provides further drill down to the message that was exchanged. Different views of the message's data are available. The model is a human-readable summary of the message. The Structure tab provides all of the richness of the standard, in this case the SWIFT MT103 format. In addition, the message is available in text format, as it was exchanged over the SWIFT network. We switch back to the dashboard with the value perspective on transactions in flight, and we will simulate a scenario where a high-value USD transaction is stuck in the transaction lifecycle. A $1 million transaction is created in electronic banking, which is visible in the chart as a blue bar in status EB created. Shortly after this, the transaction is released in electronic banking, where the color of the bar changes to green to reflect the status EB released. The event is also visible in the numeric presentation at the top of the dashboard, where it contributes to a bucket containing 2 transactions with a counter value of almost 900,000 euro. In this scenario, the transaction is not picked up for further processing. Switching to the sample alert dashboard again, we see that the $1 million transaction eventually pops up in the USB aging portlet. This portlet lists high-value USD transactions that are in a non-final status, in this case EB released, and that did not change status for over 5 minutes. We switch back to the dashboard with the value perspective on transactions in flight. After resolution of the problem, the $1 million transaction eventually reaches a final status and is no longer visible. To conclude our demonstration, we switch to a last example dashboard. This dashboard reports on the service level provided by the transaction processing infrastructure. It provides statistics on the time a transaction resides in each specific status before moving to the next status in milliseconds. In the top half of this dashboard, we can see the median processing time for each status, as well as the 5% best and worst case quantiles. These statistics can be presented graphically to reflect the median and worst case processing time in function of all hours of the business day. Additional projections of these statistics are also supported, as can be seen in the lower half of the dashboard. Any dashboard provided, whether on real-time transaction status information or on historic processing statistics, supports additional filtering of the underlying data using the search form. As an example, we will filter this dashboard to reflect only information related to processing USD transactions. This concludes the demonstration of the INTIX transaction tracker.